Hello, everyone. I'm Alicia. I'm here with Chariot Solutions, here to introduce our speaker, Tammy, Bryant, Butow, presenting chaos engineering for your networks. Take it away.
Hi, everyone. Thanks so much for joining today. I'm really excited to get to speak with you all, and I'll be taking questions at the end, so feel free to ask as we go, and Alicia will call those questions out at the end and I'll respond to them. I'm just going to share my screen now. Alrighty. Cool. Okay, so I'm joining you today from Atlanta. It's nice and green, a bit rainy here. And my name's Tammy Bryant Butow. I'm a principal site reliability engineer at Gremlin. Today we're going to be talking about chaos engineering, when the network breaks. And hi to new and old friends. If I've met you before, great to see you again. If it's our first time meeting, it's great to meet you. I'm really excited to get to meet more people who are interested in chaos engineering and practicing chaos engineering. If you've got questions, I'm always happy to answer. You can find me on Twitter at @TamBryantButow, and then also on LinkedIn. Feel free to connect with me. So like I said, I'm a principal SRE at Gremlin. I do a lot of work primarily on chaos engineering, which is something that I've specialized in as a site reliability engineer. And I also am the co-founder of Girl Geek Academy, which is a community which we've created to actually teach 1 million girls technical skills by 2025. We've made amazing progress. So you can check us out on Twitter as well. We run a lot of really fun workshops to teach girls to code, even as young as like 5 years old. And I've even run a chaos engineering workshop for 5-year-olds, which was actually so fun. They're actually quite good at it. And probably not surprising if you've got kids. So the other thing that I did before working at Gremlin was work as a site reliability engineering manager at Dropbox, where I led the databases team and then also the block storage team, and also developer tools, so like workflows, all of the internal systems for that. I've been on call for a lot of different systems. As you know, like Dropbox has a lot of users, over 500 million users. So we had a lot of customers that we were making sure we were always keeping everything up and reliable for, never losing data. That's the main responsibility of an SRE. And then we also just had a lot of different type of work to do. I was also the incident manager on call. So that means I was on call for any time that there was an incident across any system or service at Dropbox. I was the person running that whole chain of command when you have an incident and need to triage through and find the right people to get things fixed. So a very small rotation of like 7 folks across Dropbox. And before that, I worked at Digitalocean. Also super interesting. I was there very early and led a very large team. I was there for quite a while, great team. That was looking after 14 data centers. So also very interesting. Lots of different things can go wrong when you're working at that scale, building the cloud for others. And prior to that, I was at the National Australia Bank. So I also did a lot of chaos engineering really early on. Back in 2009 is when I really started to do it professionally, getting paid to do it. And back then we were doing large scale failovers. So let's take down an entire data center and fail over to another one. So I got to do that on a quarterly basis, make sure that all of our mortgage broking systems worked, internet banking, foreign exchange trading. And prior to that, I worked at Queensland University of Technology, making sure that all of those systems were up and running. I actually worked inside the on-campus data center, which was pretty cool. So I actually started like probably my real paid jobs doing a lot of freelancing, building things, but also working inside a data center, doing system work with Linux, but also with Windows. So yeah, lots of interesting things along the way. And all of that's led me to love site reliability engineering and chaos engineering. So have you ever thought that the network was causing an issue, causing an incident, but you've struggled to prove it? I'm sure many of you have had this feeling where you're like, I really think it's the network. And you're just like, but how can I prove it? Like, what data can I show people so they believe me so we can actually debug this, look into it and get it resolved? So what you do is you get out your network tools to try and collect some evidence, because, you know, the network engineering team, they're always like, hey, you know, I need some data to be able to prove this. what can you show me that explains what's happening, or other engineers on your team want to be able to see that data. So, you might use TCP dumps, get some PCAPs, use Wireshark, maybe other tools as well, like Thousand Eyes. I really like that tool. I got to use that starting at DigitalOcean and brought it over into Dropbox as well. And that's like a great, amazing tool to be able to see issues across the network within your own network and also externally. There's a lot of really complicated things that can go wrong with networking. So, you try, do your best, but then often everyone still is like, nah, it's not the network. Like, I just don't think it looks like it is the network. They might say it's something else, like it's the code, or it's a server problem, or it's a Linux issue, or it's an application problem, or, that's like a kind of a flaky little blip, but can you really prove that it's a networking issue? And so it's kind of hard to like get that evidence. And also because things can happen sort of like intermittently, not all the time, but just sometimes, which makes it even harder to prove. And as we know, like one of the best ways to prove something is if you can reproduce it, but it's kind of hard, right? To like reproduce these networking issues. But this is what you can do with chaos engineering. So at this moment, when you're like, all right, I need to do more to prove this, I need to try and reproduce this issue, you can then get started with network chaos engineering. So what is network chaos engineering? It's really thoughtful, planned experiments designed to help you prove networking issues and get them resolved quickly. So when you think of chaos engineering in general, I'm sure a few folks on the call have perhaps even practiced chaos engineering already. Maybe you're doing it as your role within your organization, or maybe you've practiced it a few times over the years at different organizations. Maybe you're curious and you're interested in getting started with chaos engineering. That's awesome too. There's a lot of different ways that you can use chaos engineering. And historically, like a lot of people know that chaos engineering really started, the concept and the term came from Netflix, right? So Netflix created this tool called Chaos Monkey. And they also created a team called the Chaos Engineering Team. That was Bruce Wong over at, I think he's at Stitch Fix now. He then created that. And he then was like, one of the best things we should do is just inject failure. And they were moving over to AWS at the time, migrating away from on-prem and doing this huge cloud migration. So they wanted to move everything to EC2 instances. So the idea of Chaos Monkey is that it would randomly shut down an EC2 instance or host to make sure that people didn't hard code things, and make sure it wasn't like this application requires this specific server to be up and running. Sometimes you'll see code written like that. And they wanted folks to realize like these servers could go away at any time. We're not managing them ourselves. It's a service that we're relying on. So just get ready for it to fail, to reboot, to restart, to be cleaned away, to have to go through maintenance. Like we don't control any of that. So we can't change the schedule for you. And after that, a lot of value came out of that work. And that was like really a very clear, simple use case, right, for chaos engineering. Since then, it's expanded. So now it's not only about shutting down a random host, it's really about this idea of thoughtful, planned experiments that actually can be quite advanced and use a lot of different types of attacks, is what we call them now in this field. So for example, with networking, it could be latency, packet loss. There's a lot of different types of things you can do. Another very popular attack type now is called black hole, which means let's make this traffic actually not reach the destination. Let's just make it go into a black hole, make it disappear. So that's a very interesting advancement in that field too. So for example, say you've got this situation where somebody is occasionally throttling your traffic. How do you discover and prove this? And so the answer is network chaos engineering, because what you can do is you can actually try and collect evidence to try and reproduce this scenario to prove that it's happening. And this comes from a real story. This is something that really happened to me when I was working at Dropbox on the databases team. We saw that there was something strange happening with the network, but it was difficult for us to prove it. We'd like ask people if they'd changed anything, if anything had happened, if there was anything that was recently altered, but nobody had any answers. We still kept seeing these problems. So we're like, all right, well, we're just gonna have to do a lot of testing, run a lot of experiments, and then be able to try and prove that there's something wrong. So what we did was we actually generated network traffic. So a lot of the time, what we can do here is, if you think, how do you generate network traffic for a database system? There's a lot of things I'm sure that come to mind. One is you can trigger backups to run. You could trigger restores to run. You could trigger a database to be cloned. You could trigger a promotion to happen, a database promotion to go from a replica to a primary. There's a lot of things you could do. Or if you wanted, if you were working on a staging environment, we were doing this in production, but if you were working on a staging environment, we have the ability to, for example, like replay database traffic, database requests. We built that tool ourselves and actually open sourced it. It's on GitHub. We worked on it with the Butow team. So that's also another cool thing you can do in a staging environment. But I like the idea of, not just thinking about the database, but all of the actions around the database that need to be reliable, right? Backups are so critical, so are restores, so are promotions. So let's generate that network traffic by triggering a backup to run or triggering a promotion. We then observe the network traffic. So what's the best way to observe this? It's like using all of our different tools that we have. So we might have dashboards, we've got logs, we've maybe got other tools that we've purchased like Thousand Eyes or Datadog as well, New Relic, all these different types of tools you can use, Splunk. I've pretty much used all of these tools over the years at different places that I've worked, and they're all great in different ways. It really just depends on what you've got available, I feel, and then like making sure to use those tools in the best way. But observability, monitoring, and then actually understanding that data is really important. That takes some time, right? But the other cool thing with network chaos engineering is that you can use these experiment situations to actually understand your data better, to understand your systems better, to understand your network better. So we're going to observe what's happening first to understand and get some baseline metrics. So for example, it takes us X many minutes, let's say 60 minutes to run a backup. Let's now run a latency attack. So that's actually going to make the network run slower. Let's inject some latency. Now let's see if that changes how fast we can run our backups. So that's an example of what you can do. And then let's review the results. Let's actually see, is it still 60 seconds? Does it look like things go slower? Could we see this impact in our observability tooling? Are we able to actually collect data to prove that there is latency impacting this system? Like, where do we find that? Because that's what you really need to share with others. So you realize when you're running these experiments, when you are seeing your actual networking issues and not the ones that you're creating, but the ones that are happening just randomly, you're thinking it looks a lot like misconfigured QoS, only throttling you during specific time windows. So that's a tough thing to figure out, right? But you're like, this actually, it does look like that. It looks like maybe there's some type of setting, some type of policy, and it's really looking like latency is being added just during specific time windows. And to get to this conclusion, takes experience, takes understanding, takes a lot of different types of knowledge, but everyone can get there with just curiosity and different types of ways to think. This idea of like, let's experiment, let's try and learn, let's look at our data. Now let's look back at the original data. Let's see if we can do any pattern matching. So what is QoS? If you've never heard of QoS, it is quality of service, and it controls and manages network resources by setting priorities for specific types of data on the network. But if QoS is misconfigured, it can add latency as the wrong packets may be getting delayed in a buffer when other traffic is present. So for example, what you can do is with QoS is you can say, I would like to throttle all traffic by this service. Like, it might be a service that's not so critical, maybe like email notifications or something like that. Something where you're like, we want it to go out, but it doesn't have to be exactly on time all the time. You can have a little bit of a delay. And so the idea of QoS is you want to prioritize critical network traffic and have lower priority network traffic not be as fast. Let's say I want this traffic to go ahead, similar to doing like traffic management within the lanes on a freeway. You can have a VIP lane. That's what QoS allows you to build, like a fast track lane. But it's difficult to get it right. So this is something that I once heard. A bad QoS policy is worse than no QoS policy. And a lot of the time what ends up happening is folks will actually create QoS policies, but not tell you that they've created them or not explain how they were created. And sometimes there's no internal communication around this, code review, being able to actually just confirm and check with people that are being impacted that they're okay for this to happen. And one person could just create this policy and then suddenly it's impacting all of your network traffic within your organization and it's difficult to debug. So this is something that really happened to me. We had our networking traffic for databases being slowed down because of a policy. But what we could do then, because we had this data, we'd been able to collect this information, we were like, okay, we can now resolve this issue by fixing the misconfigured QoS policy and then putting in place a notification system for service owners. So whenever you find something wrong or something, you know, that could be improved within a system, what you can do is you can think through, like, a question I love to ask: how can we make sure this never happens again, this specific scenario? So like, this is a thing that could totally happen again, right? In a year, in 2 years, when someone new joins the team, maybe they think it'd be great to do this again. And so what you can do is you can say, every time a new QoS policy is added or changed, like, let's just send an email notification to the service owner. Let's make sure that they're on that thread, for example, for any changes. And then what we want to do too, this is really critical, is we then rerun our chaos engineering scenario to ensure that the fix works. So we want to be able to, like, go, okay, like, let's run this, let's check our monitors, check that that's all good. Let's check anything that we changed in terms of alerting to make sure that we catch problems better. So anything that you change to make this situation better, you then want to inject the failure. So in this case, latency, and then track through and see that everything works. And that's a really important point. The reason is, like, I'm sure you've been in postmortems before where everyone had all these great ideas. You went and did a few of them. You were like, okay, hope this works next time this incident comes along. But it's super important to actually test that out, right? To say, okay, we put in these fixes. Now let's inject the failure again and let's test to make sure that if that failure does happen, we're not going to be caught out the same as we were last time. So that's really critical. And I think this is also a nice forcing function. So if you're an SRE manager running postmortems, what you can do is you can say, okay, we're doing the postmortem on Monday. Within a month from Monday, everyone needs to have their action items done, because what we're going to do is we're going to reproduce this failure mode and make sure that our action items were effective. And that helps people, because sometimes folks say, how do you get people to do action items from postmortems? Like, for me, I always made them JIRA tickets. I always made sure that they were tracked in the backlog, and then also set that forcing function of 1 month in, we're going to check and see how things actually look. And after you've done all of that work, it's not time to stop. There's still a lot more to do. So next, it's time to continue advancing your practice of network chaos engineering. So there's a lot of different use cases and benefits that you can get from practicing chaos engineering on the network. One of my favorites, we've talked a little bit about it, is finding monitoring and observability gaps. You know, who monitors the monitoring? That's a really famous saying from Adrian Cockcroft over at AWS. I love that. So true, right? How often do you test that your monitoring and alerting works? The other thing that's important to do is to validate dependencies. So, you know, you've got dependencies on other teams, on external services, on third-party applications. What happens if they don't work? You know, your customers aren't going to say, oh, it's okay that your one third-party dependency wasn't working. I understand, no worries. Like, no, they're going to be angry. They're going to send in support tickets. They're going to be unhappy that your software isn't working as expected, that your application isn't working like they expect it to. They won't really care that it's a third party. They see that as your business. Like, if you are running, you know, company ABC, and then company ABC is down due to a third party dependency, then that looks like company ABC isn't doing a great job. The other thing that you can do is train teams for on-call. So this is a really cool thing that I came up with when I was working at Dropbox. I realized, like, that most of the time teams never get trained for on-call, but actually you could do some really effective training and it would make on-call so much better for everyone. So why this came up was we were adding a lot of new folks to the team. We were also trying to offboard some folks for the team who wanted to go and work on different teams because they had been there for many years and they were looking for their next interesting opportunity. So what we did was said, okay, like how can we make sure that people who are on this team know how to handle issues when they come up when they're on call? We realized the best way to do that was to train them with real hands-on practice. So what we did was we got a staging environment that we built for this training purpose. We built out some of the database clusters on those training servers, started to rerun traffic through, and we're like, all right, let's trigger some failure via chaos engineering. We're going to inject a failure. So say, for example, restores aren't working. There's some type of issue with restores, and we had that running as an automated system to make sure that it always worked. What do you do when restores don't work? Okay, there's no automated fix in that moment. There was no automated fix for restores not working, but there was a playbook that you could follow to check why they weren't working, what dashboards to look at, to be able to actually run a specific script that we created to get them working again. And so that's what we did, but we didn't do it, you know, in different places by ourselves. All of us were there together in the room. So there was 10 of us on a Zoom call. We had a team that was half in Dublin, half in San Francisco. And we just ran through these scenarios as like fire drills to be able to practice and prepare for these situations. And we actually got through 5 different scenarios or incidents that commonly would happen. And we were able to train everyone up on that. The other thing that I thought was very cool was before doing this online, this on-call training, what I did was I sent out a survey before. How confident are you that you can handle on-call situations for this team?
It looks like we're a little bit frozen. I'm going to see if we can check with Tammy to see if she's still available or her internet. Cool, I can see your screen. We're back.
Fabulous, great. All right, cool. So we just talked about on-call. And the last and final thing that is very awesome as well is being able to get more sleep. So the idea there is being paged less, which means that you're actually able to sleep through the night. And I know if you've, you know, if you're in the audience and you've been on call, one of the really hard things is being woken up, you know, multiple times in the evening. I've had some on-call rotations where we're getting hundreds of pages a week, including many pages between midnight and, you know, 9 a.m. So you might get paged at 1 a.m. Not so bad, but then you get paged again at 2 a.m. Then you get paged again at 3:30 a.m. And this is obviously really bad. And then you're expected to go into the office the next morning again at 9 a.m. So that's not very good at all. And what we always wanted to do when we're in these situations, myself and folks that I've worked with, is reduce the number of pages we were getting because we didn't want to be up all hours of the night and then have to go into work in the morning. So that's why I'm a big fan of reducing pages to be able to get more sleep. And the other thing too is, you know, you should only page for critical things. That's important as well. And by doing chaos engineering, I think one of the best benefits is you'll be able to see a reduction in high severity pages, so high severity incidents. You might get more low severity pages, but often those are things that you don't need to take care of overnight. You can just do them in the morning. So mean time to detection is actually one of my favorite benefits from practicing chaos engineering. And this means you're able to detect incidents faster because you're able to catch them more quickly. And I wrote about this so much, I care about this so much that I actually wrote a book on it with friends. So you can find that. I'll share the link in the Slack, but it's just over on the Gremlin website. We made it available for free. And I wrote it with some folks from AWS, from Twitter, who also shared how they got some amazing benefits from reducing MTTD. And if you think about this, like why is MTTD important? It's because if it takes you a really long time to figure out that an incident is happening, then it means that the incident's really bad by then. And that's why you see these huge high severity incidents. It's just like thinking about a kitchen fire. If you catch it in your saucepan, it's not so bad. If your entire kitchen's on fire, it's really bad. If your entire house is on fire, it's really bad. Things just escalate over time. So getting things identified quickly is key. That's critical. And that's what CE chaos engineering can help you do. So now I wanted to show you some demos of network chaos engineering to help you see what it actually looks like in practice. So say this is our architecture for an e-commerce store that we all work at. Congratulations, you got a new job working at this awesome store called the Hipster Shop. And we have all these different services that we run and we look after. We're responsible for these. But which of these services matter most to our customers? What can we actually remove from the critical path? Is there anything here on this list that we can remove from the critical path? So for example, maybe the currency service, maybe the ad service, maybe the email service. Like we definitely don't want to remove the cart service or the payment service. So let's have a look at what we can remove. All right, so we're actually able to remove quite a lot of services. So now we just have the checkout service, the payment service, the shipping, the product catalog, and the cart and cache left over. Another thing that you'll hear a lot in Silicon Valley is that getting out of the critical path is a good thing. So this is a kind of interesting topic, but sometimes people say like, I want to be in the critical path working on critical systems. But if you can get out of the critical path, that's awesome. That means less, less oversight from other teams, less SREs coming knocking on your door, less meetings that you need to go to because you own a critical service for the business. And, not every service has to be critical. It's better to have like a small number of like 10 or less critical services. If you've got hundreds, it's probably not good. So now let's look at this demo. This is our architecture. We've got our front end, our product catalog. And let's think about this. Does blackballing a non-critical path service like the recommendation service cause unexpected failures for critical services like the product catalog or the front end? So what we're going to do is we're going to make the ad service disappear. So we're going to say, let's get rid of this ad service here. So this is what it does. The ad service creates these ads on our store down the bottom of every product page. So what we're going to do is we're going to select the cart service. We're going to run a black hole attack, and let's see what happens. We expect during our experiment when we create our graceful version of the customer, you do. You can see the ad just disappears and the page gets slightly small, which is perfect. That's an awesome result. What about when the 6-second black hole attack ends? Will everything return to normal? Yes, everything looks great. Our ads are back. Everything's working perfectly. This is an awesome environment with great results. So we have graceful degradation and everything's successful. Now let's look at a second demo. Blackholing recommendations. So the recommendation service up here, it lists out 4 recommended products on every.
All right. Someone ran another experiment. I'm going to reach out and see if we can. Oh, Tammy, hopefully he's coming back. Are you back? Can you hear me? You are muted.
Yeah, I'm back. Can you hear me?
Yes, I can hear you.
Just waiting for my slides to load. Yeah, that was a minor blip. Not sure what happened there. Definitely seeing a lot of chaos on the internet today. It's pretty common, as you'll see.
Especially with all these digital conferences running.
Yeah, this is why I do what I do. Let's see. Might have to go to my third backup internet if I'm really struggling here. We'll see. I've got a few minutes left only.
We have until 2:30, so we've got a bit of time.
All right, that's great. Perfect. Yeah, hang on, everyone. I do have actually like more backup internet options if I have to go there, but we'll see. Yeah, the interesting thing too with the internet, as I'm just pulling this back up, is it really isn't reliable yet. We, would hope that we'd be at that point, but we're just not yet. All righty, let's see. All right, switch to my third internet. Well, I'm going to try this one out. Looks better. Okay. Okay, great.
I can see your screen.
Yay, third one's the charm, hopefully. Fingers crossed.
Mhm.
Alrighty, so I'll just quickly go back over this. So what we're doing for this second demo is doing a black hole attack on recommendations. So what we have here is our recommendation service, which shows us these images and these text for different products that we might like to buy, similar to when you're browsing on Amazon. So what we're going to do is run a black hole attack on this specific service. It's running on Kubernetes. It has 2 active targets, 2 pods, and we're going to make these unavailable. So what will happen here? We'll black holing a non-critical service like the recommendation service. Like that's not critical. It shouldn't cause us a problem. Will that result in graceful degradation of the customer experience? No. So what ends up happening when you black hole the recommendation service is that the entire website just starts spinning and it can't load and you can't go anywhere and you're just stuck in this situation, which, that's obviously not good. So now we need to think, why is this happening? It's just a recommendation service, but this seems to be breaking the entire website. I can't do anything, can't make purchases, can't add to cart, can't browse anywhere. So then you can look at other tools that we might have. I've done a lot of full stack engineering over the years. And even though over the past, many years now, like maybe 8 years or so, I've done mostly infrastructure back-end work, I still find that there's a lot of tools on the front end that really help. So for example, this is our Google Chrome developer tools. And these are really handy to be able to capture network traffic and understand what's going on with your system. So we can see here, our requests for product pages are being canceled because the first product page request is stalled and unable to complete successfully. This continues for the duration of the recommendations catalog outage due to a previously unknown dependency on product assets that are unavailable. So because this service is not up and running, because it's unreachable due to our chaos engineering attack, nothing will work because there is a hard-coded dependency, which we didn't know about. And that shouldn't exist, right? We don't want that to be there. So we'd have to then look at removing that from the code. So that's a really interesting finding and a good thing to learn. It's not something we would have guessed. And obviously, yes, this is a major incident. Our experiment was not successful and our results were not what we expected them to be. But that's great. That's a learning opportunity. That's a moment where we can grow and we can make things better. We'll need to fix these dependency issues to ensure that this doesn't happen again. So we had an unknown dependency on an internal service. We need to fix that and everything should be good. We'll just rerun it again to test and make sure all is well. So now for our third demo, what I'd like to do is show you how to run a packet loss attack. So a different type of network engineering attack. And this time we're going to run it on the shopping cart and see what happens. So if you think through this, like what might happen if you were to drop packets for a shopping cart? And let's say you already have items in your shopping cart. So this is what the shopping cart looks like. We've got 2 items in here already, the city bike and the vintage record player worth $861.64. So we've currently stored those in our cart And what we're going to do here is we're going to run our experiment and try and test a few different things. Do we lose data that's already stored in our cart if we drop packets, or does it only impact transactions that are in progress? So say if we try and add new items to cart, is that not possible? So we expect that during this attack, it should be difficult to add new items to cart. They might actually fail, but we don't expect that we should lose items in our cart because we have a Redis cache that should be storing that data. So everything should be okay in that perspective, but we think that we should have a nice graceful experience. Maybe things might just be a little bit slow when we're trying to add items to cart. So let's have a look and see what happens. We're going to collect the cart service. So this is again running on Kubernetes, and we have 2 active targets. So here we're checking when we run this attack, do we experience data loss if there is a packet loss attack impacting the cart service? Wow. Okay. So it ends up that we see something pretty bad. We actually get a front-facing, user-facing 500 internal server error, which actually looks pretty ugly. It's showing, users, customers that are shopping around a lot of code, which is not good, or a lot of logs, I should say. And we can see here that there's an RPC error. And then underneath it says failed to add to cart. So this is what's being shown to us when someone tries to click to add an item to cart, a 500 error gets thrown up, and then they actually see this message themselves. So due to the packet loss attack on the shopping cart, we're just unable to achieve that and get the error. The other thing that obviously we want to be tracking here is seeing these bubble up into our monitoring and observability tooling, because we always want to be tracking the number of 500s that are being thrown, the specific error rate for our services, and also for our application as a whole. But this isn't a good situation to be in. So learning from our chaos engineering experiments, there's a lot that we can learn from the 3 demos that I just showed you, and also the story that I talked about earlier with QoS. There's a few key questions to ask yourself. Was it expected? Was it detected? Was it mitigated? Can we fix the issues? Can we automate this? And how can we best share our findings and results? That one is critical because I find as engineers, as technologists, we don't often take the time to, baseline our metrics and our story up front, gather our story together, write down some key information, but then also remeasure and collect more data at the end and package that up into a really compelling story to share with other teams internally. And maybe even you can share it one day at a conference, which is really cool to be able to share your learnings, what you were able to achieve, what you improved to help other people across the industry. But this bit is really important and often quite difficult. But something that you can do is join the chaos engineering community. So there's actually over 8,000 engineers, 8,000 of us who have come together to share knowledge on chaos engineering. If you go to gremlin.com/Slack, definitely recommend that you join in there. And the other thing that you can do, if some of you in the audience, if I've met you before, or if you've been practicing chaos engineering already, or if you know someone that's been doing chaos engineering, nominate someone awesome that's already doing it, or nominate yourself, and you could receive a Chaos Champion Award, which is pretty cool. If you go to gremlin.com/champions, that's a way that we're recognizing folks in the industry. We've got some really cool plans for folks there too, like champions will be able to receive a ticket and accommodation and great seats when we eventually do run events in person again, to be able to come along to ChaosConf, which is our yearly chaos engineering conference that we run. So that'd be really cool. So definitely do that. And just wanted to thank you so much to new and old friends. If you have any questions, I'm happy to take those now. And then I also wanted to say, as a gift from Gremlin, we're giving you a bonus sticker gift pack, which you can get if you go to gremlin.com/talk/ETE. And these are some really cool stickers that we designed. They're kind of like tattoo, Sailor Jerry style stickers, but they've got fun incident management and chaos engineering images. Like you can see here, there's a pager with an UG on it and some other really cool designs. So definitely check those out too. Awesome. Thank you so much.
Thank you very much. And thank you for having 2 backup internets so we could hear this full talk. We do have a couple of questions, so I'm going to roll into those. The first one, I do Zoom questions first because they do disappear at the end of the talk, so I'll prioritize those. Since you mentioned on-call rotations, how do you manage reserving backups if people cannot take up on-call for a given week? Just curious to know if there's any best practices.
Yeah, love that question. It's definitely something that comes up. I find it's good to figure this out based on the culture of your organization. My personal preference of what's always worked well for me is to actually, I have a lot of ways to do this based on in the past when I worked in a shift style role, actually at KFC, right? There's a lot of people that have to manage shifts, and I did that as a teenager. And the first thing that you do is you say to folks who are on call, say if you're managing that team, or if you're on that team, you can say, hey, like the first thing we should do is try and find someone to take over that shift. So that's always the best thing, is like, say within the team, like just try and find a friend to take your shift over and do like a trade. Say, hey, I'll take this week if you take this other week going forward, because I want to take a vacation in that week. I find that's like the friendliest way to do it, and it's really nice. If that doesn't work well, because maybe culturally it doesn't work out so well, then the next thing to do is just actually say, ask the manager to just manage this as part of their job. So your manager of your team that's managing the on-call rotation could just manage this. And that's also totally fine and totally acceptable, just like they would manage vacation and leave and approvals and tracking for that. And then it would be their job to find someone to be able to take on that rotation. And if they can't find someone, then the manager's job is to take on that rotation, really. Like, I think that's what it comes down to. So those are my tips there.
Thank you. And we did have another question. How often has buffer bloat been a root cause or approximate cause of errors?
Yeah, honestly, like I wouldn't say it's frequent, because there's so many different things that go on when you're doing chaos engineering. This is the biggest thing that I've learned, is it's often actually something different. So, and the thing too is the more you do, the more issues you find. So the deeper you go into an area, the more problems you'll identify and then you'll have to fix. And I would just say, like, I originally thought, oh, we'd be able to like say, the top 10% of things we identify in chaos engineering is X, but it's really not like that. It's really different based on the people working on the team, based on the technology being used, based on how things are built, based on the underlying infrastructure choices, different third-party choices, just a lot of different interesting things going on. I will say, though, there's a great repo of incidents that have happened. And I actually went through, there's two. There's one that's a great repo on GitHub, just all incidents that have happened and people have shared postmortems. I looked at that data and crunched it to identify the causes. The number one issue was actually configuration related. So people making incorrect configuration changes, and that's similar to this QoS policy story. Like someone just didn't do the right thing by accident, and then there was an outage. That's the most common. But it's interesting when you look at Kubernetes, it's actually different. So there's another repo of Kubernetes outages. And the most common Kubernetes outages are not caused by that. They're actually caused by resource constraints. So CPU is actually the biggest one. And it's CPU throttling, CPU spiking. So yeah, it's super interesting. If you cut and slice the data, you'll learn all sorts of different things. So that's very interesting. Cool. Thank you.
Is there a good way to keep Qos policies such that they're visible and easily shared for everyone to see?
Yeah, I love the idea of like with the networking team, like thinking that this is like networking as code. That's like super important, and putting this within your repo so that everyone can see that. Like if you have, say use GitHub, asking the network engineering team to make that visible for other teams. And then that means you can actually tag people if their service is in that policy so they can get a notification. But this is really like going forward into this world of like configuration as code, like let's track everything, let's get reviews, let's have audits in place. Like it just makes things so much better. It's like a little bit more work, but having a centralized repository of all of your configuration will result in just less issues later on and make sure that the right people are in the loop. And I think obviously it reduces incidents, reduces downtime and issues for customers. So there's only great things that can come from that. But that's definitely what I would say for all networking related things, is to move towards that type of work style. The other interesting role that's been created, which I think helps here a lot, is network reliability engineer. So the NRE, if you Google that, that's like a whole new field of role and work that you can do, which is all focused on keeping networks up and running. So love that too. And they're coming up with a lot of great ideas in that area. Thank you.
Thank you. What tools are available for chaos engineering for non-cloud data center hosted environments running apps on VMs?
Yeah, great question. So there's a lot of different tools for on-prem and running your own data centers. That's how I started doing chaos engineering at the National Australia Bank as well, and also at DigitalOcean. We're running our own cloud. So Gremlin, obviously, like we provide a chaos engineering platform. Gremlin works on your own data centers. All you need to do with tools like Gremlin is to be able to just have a proxy. That's usually what our customers will do. You'll just have a proxy to be able to make sure that you can communicate with the Gremlin control plane, which lives in AWS. But that's really similar for a lot of these chaos engineering tools. You install your agent. So that's how these tools work primarily, is you have an agent running on your machines, and then they have to be able to reach a control plane. So it's just making sure to punch that hole, proxy through, like make sure everything's good. And then they have to be able to reach back to the host. And it's just saying, I would like to run an attack on this host. No sensitive data has to be sent. And then you run the attack and then send the results of the attack. And that's really it. So any of the tools, you'll see they run in that way. The really great ones, I think. And so that's what I would check out. The other thing too is, like, I guess I started out by building my own tools. So if you are looking at, being able to just start and do some small experiments, you can definitely try and do that as well. So yeah.
Thank you. And do you have any suggestions on how to get your organization to prioritize chaos engineering?
Yep. Yeah. One of the best things to do is to figure out how much it costs if you're down for 5 minutes or a minute. So when I talk to folks, they'll actually not know straight away, but then they go off and do that calculation. You might have to talk to the product team or the finance team to understand that. How much do we make in 5 minutes generally? And so if you were down for 5 minutes, that's how much money you would be losing. Sometimes folks are like, oh, we lose $200,000 for 5 minutes, or we lose even more than that for 5 minutes. And so that means that you're able to say, well, if we can do more chaos engineering to be able to reduce downtime, that's what we could save. Like, we'd be able to actually make sure that we could continuously allow our customers to use our products, and we wouldn't be just losing money when we had outages. I feel like that's the best way to get started, is to talk about it like that. The other one that I like to use is to say, chaos engineering is a great way to be able to help us reduce the amount of incidents that we're getting. So if you've got a huge load of incidents happening all the time, you can say that as a good argument. And it's just a really proactive approach to reducing incidents. So that's very important. The other thing that I like is, if you're moving to the cloud, a great use case for getting started with chaos engineering is making sure as you lift and shift your applications that they work as expected by injecting failure on purpose, because it's a really quick, fast way to learn. And a lot of folks do that as they move to the cloud, or as they go multi-cloud, like using Amazon and Azure. That's another good use case. But I think the best thing to do is to get started around these specific use cases, specifically around a pain point that you have in your organization. If it's downtime, if it's incidents, if it's a big migration coming up, or maybe your team's not so great at decommissioning old systems, you can use chaos engineering to get evidence that that should happen. Or I've even used it to be able to get headcount for my teams. So there's a lot of cool things you can do. Thank you.
Thank you very much. I don't see any further questions, so we'll wrap up. Thank you very much. That was an excellent talk. And I hope you have a great afternoon with fewer network outages.
Thank you so much. Thanks, Alicia. Thank you everyone for coming along today. It was great to meet you, and I'm excited to get to continue speaking with you and supporting you on your chaos engineering journey. Let's do this.
Thanks. Have a great day, everyone.